Write the equation 2x squared plus 8x plus 2 in graphing form by completing the square. Then identify the following. So first, by graphing form, remember, ladies and gentlemen, this was y equals. In order to do graphing form, we want this leading coefficient to be 1. Right now, my leading coefficient is 2, so I'm going to divide everything by 2. And that's going to leave me with x squared plus 4x plus 1. From here, now that my leading coefficient is 1, I can complete the square. And whichever way you choose to do that, you can do the draw it out method. I have 4 x's, so I'm going to put 2 on this side, and I'm going to put 2 on this side. And then in order to complete my square, Ransom, I'm going to add 4 ones. In order to keep it a balanced equation, I then also have to subtract 4 ones, right? I can't just pull 4 out of thin air. Does that make sense? Okay. So now I have this equation of x plus 2 times x plus 2. And this equation comes from these first terms right here. And then I have this negative 3 left over. And what that's going to look like is this. Y divided by 2 equals x plus 2 squared minus 3. My last step with completing the square is I still have that 2 hanging out with the y. I have to multiply it back in. And it's just like it's distributing. I have to multiply it to both of these terms. So if I multiply 2 here, those are going to cancel. And then I'm going to multiply that 2 to this term here. And I'm going to multiply that 2 to this term as well. And that leaves me with y equals 2 times x plus 2 squared minus 6. That is the graphing form. That is A to your worksheet. All of this work was for A. This is graphing form. This is the AHK, okay?
Are you not going to be here after school?
I will. B, I have my vertex. Okay, my vertex is going to be the opposite of what I see with my x. And then my constant. So HK is my vertex. So in this case, my vertex is negative 2, negative 6.
It's the 2 that's in the
Opposite sign that you see, 6. No. Because I said no. See, axis of symmetry. The axis of symmetry is the x value of your vertex. So my x value, ladies and gentlemen, right here. Remember the x from the coordinate? So my x value is x equals negative 2. That means that if I wanted to draw a line straight down the center of this parabola, I would be going through the negative 2, 0. Like a straight line through that point.
Are we allowed to use our registers on this?
I don't know yet. I'll let you know tomorrow. Real or complex roots. In order to know from this form, if I have real or complex roots, I have to solve for y equals 0 and solve for x. So real or complex roots, which would be our D. So now that it's in graphing form, to find our real or complex roots, I do 0 equals 2 times x plus 2 squared minus 6. And then I'm going to just solve for x. So I'm going to add 6 to both sides. So 6 equals 2 times this. And then I'm going to divide by 2 to get rid. We're just working PEMDAS backwards in case you guys are like, what are you doing, Ms. Warrenson? Working PEMDAS backwards. Remember, when we use the order of operations forward, you're simplifying an expression. When you're solving for a variable, you're working PEMDAS backwards, or order of operations backwards. And so we're simplifying that down. We have 3 equals x plus 2 squared. To get rid of this squared, all I have to do is square root both sides. So I have plus or minus the square root of 3 equals x plus 2. And then my last step in this is I have to get my x alone. So I'm going to minus 2 from both sides. So my roots are going to be x equals negative 2 plus or minus the square root of 3. Are these real or complex? Why? I don't think a square root makes it complex. What makes it complex? Caleb. A square root of a negative number. I heard it over here too. I heard I. Right? The square root of a negative number makes it complex. Don't get that confused. And that's why I kind of let that roll. Guys, the square root just means it's a square root. Right? If I did the square root of 3 in my calculator, wouldn't I just get a number? It'd be a yucky decimal, but I'd get a number. Right? Square roots are not complex. The square root of a negative number is. Make sense?
Yes.
So this has 2 real roots because of the plus or minus right here. Plus or minus makes it real. I meant 2, not real. All right. And then y-intercept as a point. Guys, do not get mixed up. Do not get mixed up here. When we have, this is E, not D, okay? We have 2 forms. We have standard form, which was 2x squared plus 8x plus 2. And we had graphing form, which is y equals 2x plus 3 squared, I meant 2 squared minus 6, okay?
Can I go get some tissues from the nurse?
Oh, yeah, I forgot. Go ahead. If I put 0 into standard form to get my equation, to get my y-intercept, it would be what? 0. If I put in 0 for x, what do I get?
Is this E?
2. Right? If I looked at this, so this is one of those things where you're like, you have to really watch yourself. If you looked at this, you went, oh, my y-intercept is negative 6. I had many people in the last class do that. But friends, if I put in 0 for x, I then have to perform some math. I know. So I have 2 times 0 plus 2 squared minus 6. What's 2 squared, friends? So I have 2 times 4 minus 6. 8 minus 6 is 2. Same answer. You should get the same answer, right? But I'm just warning you, in graphing form, don't just look at the constant. The only time that trick works is in standard form. Does that make sense? The only time the trick works is in standard form, which you're given. You can look at that from the problem. You just have to remember which one to use. And that ends number 2. Number 3 says, given the function f of x equals x cubed minus 3x squared minus 7x plus 9, answer the following. Is x minus 1 a root? Okay, is it a root? Is it a factor? How do I figure that out? There are 2 ways, my friends. 2 ways. The first way, you can divide. You can use any of the 3 methods that you would choose on this, but you would divide, right? I like synthetic division, but if you use long division or you use the Polydoku or working backwards with the rectangle, you'll get the same answer, okay? So remember with synthetic division, I want to set that equal to 0 and solve. So x equals 1, and I'm going to put that up here. And then I'm going to take all my coefficients. So 1, negative 3, negative 7, and positive 9. I'm going to bring down my first term, always with synthetic. 1 times 1 is 1. I'm going to put it there. Negative 3 plus 1 is negative 2. 1 times negative 2 is negative 2. Negative 2 plus negative 7 is negative 9. 1 times negative 9 is negative 9, and I get 0. I have 0 here. Do I have a remainder? No. Is it a factor? Yes. No remainder. Yes, a factor. Okay. So, yes, this is a factor. There's no remainder. Okay. Another way to figure out if this is a factor is I take this 1 and I plug it in here for x. If I plug in 1 for x, and so I get 1 cubed minus 3 times 1 squared minus 7 times 1 plus 9. So that's 1 minus 3 minus 7 plus 9. This is 0, right? If I get 0, it is a factor. These are 2 ways, if given a potential factor, to check. You can divide, you can plug it in. You can divide, or you can plug it in. Either way, you're looking for 0. 0 is your remainder, or 0 is your answer. 0 is your answer, it is a factor. 0 is a remainder, it is a factor. Okay? Okay?
Yeah.
Okay. Now, part B of this says, okay, so this is a factor. I want you to list all of the possible ones. This is a little, we kind of skimmed over this in the lessons. We've done it, but many of the students in my other classes have not remembered, which is one of the main reasons I wanted to there was some stuff on this in the other 2 classes that kids were just like, I don't know how to do any of it. And so I'm trying to circumvent that by pulling you guys back. That Easter break, man, we had so many people forgot how to do things. So we're going to circle back to the very, very first problem. So this one, okay? In order to find out a possible factor or root, remember factor and root, we can use those interchangeably for our purposes, okay? You're going to take the constant and you're going to divide it by the leading coefficient. Okay? So in that case, we're going to take my constant. Looking at this problem, up here. What is my constant in this problem? Yep, my constant is 9. What's my leading coefficient? 1. It's not written, but if there's nothing in front of the x, it's 1, right? So 9 divided by 1 is 9. What are all the factors of positive 9? These are the possible factors of this. Possible does not mean actual. It just means possible. You can have possible factors and none of them be a factor. Just possible. Right, son?
So, what's that list of factors called in the curly brackets?
Possible factors.
Okay. So if the list of possible factors is odd, does that mean it's always the square root, or the perfect square?
Just happen to be.
But don't they come in pairs? So,
16.
that's a perfect square.
1, 2, 4, 8, 16.
Yeah, it's a perfect square, so it has an odd number.
Uh-oh.
This is fine, so.
I don't know. 25, 1, 5, 25, 3, maybe. I haven't checked them all. Possibly.
Why do we have 7?
Come again? I didn't hear you.
I'm confused.
I didn't hear you.
Oh, wait.
Oh, okay.
I sent it to the girl after.
Okay.
Which was the constant, just like the number without an x?
Yep. All right, and that's done with B. C says solve for all of your roots. Well, the good thing about doing the long division or the synthetic or whatever in the very beginning means now I have this down to a quadratic. If I have it down to a quadratic, what can I use? To just in case you guys didn't hear, I now have it down to a quadratic. I know that x minus 1 is a factor, so I can write it like this, yes? And so to solve x squared minus 2x minus 9, I can use a quadratic formula, or I can try to factor from the division. And so I'm going to choose to do, I can't think of a number off the top of my head that would multiply to give me negative 9 but add to give me 2. So I'm going to choose to do quadratic formula. You don't have to, but, I mean, you actually do because I don't think it's factorable. But I'm going to choose to do that. So what's my A value?
Your A is 1.
What's my B value?
-2.
And what's my C?
-9.
Okay, so the quadratic formula is negative b plus or minus the square root of b squared minus 4 times 1 times c all over 2 times a. Reducing that down, we have 2 plus or minus the square root of 4 plus 36. Is that right? Yeah. Over 2. 2 plus,
Why do you think it has negative 9?
isn't,
Oh, it is negative.
isn't it negative 9?
Sorry, no.
Yeah. Okay. I was like, I did it fast. I could be wrong. All right. So now I have 2 plus or minus the square root of 40 over 2. I can reduce the square root of 40 to 4 and 10. So 2 square root to 10. So I have 2 plus or minus 2 square root 10 over 2. If I have something that, if this number right here is also divisible by the denominator and this is divisible by the denominator, I can reduce them. I should have started over here and worked that way. Apologies. So that's going to be 1 plus or minus the square root of 10. X equals. So my 2 factors, friends, or my 3 factors are x equals 1 and x equals 1 plus or minus the square root of 10. They are all real roots. There are no i's. They are all real roots. There are no i's. Yeah.
What are all the possible ways? List them without check.
139.
Those are because it's the factors of 9,
The factors of the constant divided by leading coefficient.
which is 9.
Yeah. 4. Number 4 says a unit circle has an angle of theta in standard position on point P. And ladies and gentlemen, I'm just going to pull this sheet over because I don't want to draw this circle. I want you guys to remember that a point on the unit circle, you're being rude. Point P on a unit circle is always written cosine theta, sine theta. Guys, these are not trick questions. What is the cosine of theta? You're literally just looking for your x value. That's it. I think it's, I need my glasses, but it's negative 3, square root of 3 over 2.
Yeah.
Done. What's my sign?
Negative 1/2.
-1/2. Okay? Now it says, what is the measure of angle theta? This is the part where I've had some people have some trouble on this worksheet. You always start from over here. So you're going to go all the way around. Once I hit here, I know that my measure is going to be over 180 degrees, right? Okay? How do you figure this out? Well, this is a reference angle. What is my angle? What is it referencing to in my first quadrant?
30 degrees.
Yep. So there's 3 angles in my first quadrant. You know it because it's square root of 3 over 2, 1/2. There's 3 angles in my first quadrant that I said that you should probably know. 30, 45, 60. And if you know 30, you know 60 because they're just swapped. Right? So 30 degrees, square root of 3 over 2, comma 1/2. 45, square root of 2 over 2, comma square root of 2 over 2. 60, flip them. 1/2, square root of 3 over 2 over 2. Those are the 3 angles. If you know those 3 angles, then you can do almost any angle on the unit circle. The next 4 that I would implore you to know would be your 90, your 180, your 270, and your 360. You can figure those out though. Yes.
Wait, 2 questions. When you said for 60, it's negative 1/2 and negative.
60 degrees is 1/2, square root of 3 over 2.
Okay, you said
It's
square root of
positive.
3 over 2 over 2. So it's
Okay, I misspoke.
okay. I wasn't sure. And then the second question is, it says cosine of theta, but isn't that just the cosine of this little angle?
Nope.
Like,
Theta is the whole angle.
but so that's the same one for 110 too.
If that's the reference angle in the second quadrant, yeah.
Okay.
What is the measure of this angle if halfway is 30? If halfway is 180, and then this reference angle is 30.
210.
180 plus 30, 210.
4, 7, 6.
Yeah, and I'm gonna go over that right now. Because, ladies and gentlemen, remember when you're doing a quiz and or a quiz review, it is vital that you read the entire quiz review or the entire question. It doesn't just want it in degrees, which we did. It also wants it in radians. Ladies and gentlemen, in order to switch from degree to radian, it's super simple. All you do is multiply 210 by pi over 180. Do not multiply out pi. So you have 210 pi over 180. And if you want to do this slow, if you don't want to use your calculator, 210, 180, you could reduce that to 21 pi over 18. 21 and 18 are both multiples of what? 3. So what's 21 divided by 3? 7. What's 18 divided by 3? So this is my radians. This is my degrees.
I'm confused about how you knew, like, to find the measure of angle theta. Like, how did you know it was what to do with 210?
Because its reference angle is 30 degrees. So it's 180 plus 30 degrees.
Wait, that's what that point is referencing?
Mm-hmm.
Okay.
Yes, ma'am. For the next 2, friends, make sure that your calculator is in degrees because look, it has a degree symbol and this one actually doesn't say, but assume that it's degree. And then just use your calculator. Sine of 115, enter. It's like 0.9 something, I think, right?
0.0906.
0.09?
0.906.
Yeah, 0.906. So x is approximately this. And then when you have this, in order to change places, in order for your x and your number to change places, you use inverse. So on the calculator, it looks like the cosine negative 1. 11 over 12 equals x, and that's 23 point something, right?
Yes, sorry. 23.56.
0.56. Again, these are both calculator efforts. Like you don't have, I don't say you don't have to think, you just have to know how to use the tool given to you, right? All right, got 10 minutes. Think we can do it? All right. Number 6. Number 6, it gives you f of x equals negative 3x times x minus 5 cubed times x plus 2 squared. A, the degree is 6. Is that true or false? All right, I think I heard it. Oh, sorry. It's true. And here's why, just in case you're not sure. That's too thick. Okay. So, what's this exponent degree here? Right here? Is 2. What's this? 2 plus 3 is? What is this one right here? 2 plus 3 plus 1? 6. This is a 6th-degree polynomial. When it is in factored form, I want you to hear my voice. When it is in factored form, you add your degrees. When it is in standard form, you use the highest degree shown. So if you need to make a note to yourself, make a note to yourself. Factored form, add your degrees. Standard form, highest degree shown, highest exponent shown. And then just in case you're curious, this is an example of standard form, 2x plus 8x plus 2. This is a somewhat factored form here. Highest degree shown. Okay? This is actually graphing form, but.
Oh, so it's like the one with the parentheses is like the graphic form.
Oh, well. Like this one right here, standard form. Okay?
Do you take the highest degree for that one?
This one right here, this is starting to become factored form here. Standard form, all your terms are being added. Factored forms are being multiplied.
So tomorrow we have to be able to recognize standard versus factored.
I mean, you should have, yes, that should be in your repertoire. I can't say it now. I said it, but it doesn't sound right.
Can you spell it?
It's French. All right. B. It has 6 distinct intercepts. True or false? 6 distinct, another word might be unique or different. It does not. That is false. It has 3. This is 1. This is the second one. This is the third one. C, the range is all real numbers. Range, not domain.
False.
I agree. Why?
It's even.
Yes. Ladies and gentlemen, even degree ranges are restricted. Even degree ranges are restricted. So 2, 4, 6, 8, 10, restricted. Odd degrees are all real numbers. What that means, I'm going to give you a quick why. So even degree range are restricted. Okay? Here's a visual of why that is. Even degree, I know this because both of my endpoints are up. Range is the y value, right? Can this graph go lower than my blue line? No. My range is restricted. Okay? Odd degree. Can my range go lower than these arrows or higher? Yes, because the arrows mean it goes on forever and ever and ever. Okay? Even degree restricted, odd degree, range is all real numbers. Even degree domain is all real numbers. So for both even and odd, your domains are all real numbers. Okay? If you don't remember this, you guys go back and study those notes. Remember when we did the one on the board? And it, like taped all the graphs to your back? Like it was part of that era
Oh.
of math. The era. Taylor Swift telling you try to get away from her and she like pops her. All right, it passes through the origin. True or false?
That's true.
It is true. How do you know by looking at that if it passes through the origin without graphing ransom?
It has no constant applied, so it doesn't.
Ooh, I like that. Anything else to add, Sayla?
The negative 3x is going to make the whole thing equal 0 no matter what the other two are.
As long as your x equals 0, that zero product property, yes. Michael, did you have anything to add? Okay. This negative, he said there's no constant term right now, which is kind of one of those indicators. This negative 3x is your huge red flag right there. That's your red flag. If it goes through that, you should be waving a red flag that goes through your origin.
So if the x is negative?
No. If there's an x that doesn't have a constant being added or subtracted to it.
Can you explain that in different way?
Yeah. See this x minus 5? See how the x has something added to it or subtracted from it?
Yeah.
See this x plus 2? See how the x has something added to it?
Yeah.
This x right here, if I set that equal to 0, what is x?
0.
If I make my x 0, that has to go through if I make my y 0, x has to be 0. That has to go through the origin. If I make my y 0 on this one, 5 is an option. E, 0, negative 2 is a root. Is that true or false?
False.
Why?
It's a y-intercept.
It
Coordinate
is.
is a y-intercept. As well as the fact that x plus 2 would lead to a root x. And negative 2 is not 2.
Correct. Just in case you didn't follow, or I'm doing the video too, if you didn't hear, that could be, is it a y-intercept? I haven't graphed it.
Because it would have to be 2, 0, not
Correct.
0.
In the original equation, you have this x plus 2 squared, which would be x plus 2 equals 0. X would have to equal negative 2.
So it's false?
Well,
Yes. Both ways.
kind of. Think about it. It's a trick question. It is false. It is false. But this is a y-intercept. This is not an x-intercept. They're trying to trick you.
So either way,
They're just trying to trick you. A y-intercept is not a root. It's always false. But they're trying to trick you because you're going to look at that and go, oh, well, 2 is a root. So it's a trick question.
It is.
Well, negative 2 is a root. Do you see why, or do you want a little bit more on that?
No, that makes sense. We get more on that.
Yeah. Look at the equation. I think if everyone stares at the equation for just a second, it's 0, 2. In that case, that's a y-intercept. Y-intercepts are not roots. It's just trying to trick you. If it was negative 2, 0, it would be a root
Wait, how do you know that negative 2 is the root?
from the equation. If I set that equal to 0 and solve, it'd be a root.
Come on, Spartan, we gotta push through.
I know, I don't know if we're gonna have enough time.
Can you start backwards then?
This is the last question.
I know, but start with like part D.
Number 7. Number 7a. We have open parentheses 4x to the third power. This 3 or third power gets distributed to both. So it would be 64x to the third power. 4 to the third power times x to the third power. B. We have negative 3x squared y to the second. Again, that squared or that second gets distributed to all 3. So you have negative 3 squared, x squared squared, and y squared. Negative 3 squared is 9. X to the second power to the second power, a power to a power, we are going to multiply. Thank you.
It doesn't matter for this one.
And right, it doesn't for this one. It's kind of a poor example. And then y squared. See, don't let these scary berry numbers scare you. Negative 2 over 5. There is nothing that y'all can do with that. Leave it negative 2 over 5. Do not try to put a decimal in this. 613, 621.
You subtract.
You're going to subtract your exponents. So it's going to be negative 2 over 5, x to the 8th in the bottom. And then D, if you want the answer, 7 times 3 is 21. 8, x to the 8th times x to the 3rd is x to the 11th. And y to the 5th times y to the 2nd is y to the 7th. Here endeth the quiz review. Have a great day.